This is our CPE185 final project presentation. I'm Jet Valdez.
My name is Terry Fun.
And my name is Chan Yo. So for our final project, we decided to make a car alarm system. What this car alarm system does is that it alerts the user once the alarm system is triggered. So once the alarm system is triggered, special simulations such as sounds, lights, and an alert message will display on the LCD. So here is a block diagram of our system. We have a motion sensor that will detect any motion that's in front of the sensor. That's connected to the Parallax Propeller microcontroller. The next system we have is the on-off switch interface. And the following component is the GPS system, which will give the user its coordinates once the alarm system is triggered. The next component is a camera. This allows the user to have a live stream of the surrounding area of what's going on. And the next is an LCD display. This will alert the user on the screen once the alarm is triggered. Next is visual lights. What this component does is it blinks lights once the alarm system is triggered, and it'll, alert the user that the alarm is going off. And after that, we have the speaker system, which scares off the thief or whoever's trying to rob the car. And after that, we have the live video, which is also connected to the camera system. So throughout our project, most of our components were done on the Parallax board with the coding done on simple IED. With the exception of the camera system, that was done on the Raspberry Pi and coded through terminal. So the first component of our car alarm system is the simple on and off switch interface. What we did here is we inserted two buttons, one for on and one for off, and we connected it to a 3.3 volts power supply. And next slide. So here's the code. We had our conditional statement run through two while loops, one for on and 0 for off. So once the system is triggered, which is 1, the alarm will go off, and by pressing the second button, it will set the system back to 0, which is off. And here's a demonstration of the on-off switch button. And this is to set it back at 0 to turn it off. So this is the first component of our project. So once the alarm system is on, there are other simulations that will happen, and Juke will be happy to present on that.
Alright, so the next component that we are going to put into our final project is going to be the motion sensor and the LCD display. So for this circuit that we tested out, we put the motion sensor and LCD display together. So the motion sensor takes in an input, and then the LCD will display an output. So this is the code that we used for our test circuit that involves both the motion sensor and the LCD display. The motion sensor, we take in our input through our motion sensor using this initialization right here, and then this initializes the LCD display. So basically, we made two conditional statements on what the LCD will display using the motion sensor. If the motion sensor is not detecting anything, then the LCD will display it's on standby. If it is detecting something, it will display that there is an intruder. This is our demonstration. And the next component of our project were the lights. And so for this one, we used a red and a green light to signify different statuses of the alarm system. So green is the system's on standby, red symbolizes that the alarm is triggered, and we're again going to use our motion sensor as an input. And again, this is our code. The motion sensor takes an input using this initialization, and we have conditional statements again to determine like which light gets lit up.
Yeah, so
And then you gotta like open the presentation.
that's the only way to do it, because it's too small to see on the.
Okay. I'll do it next slide. And then for the next component of our alarm system, we have the GPS, and so it displays our location. It's a primitive GPS, so it's not like modern GPSs that shows us our location on screen. All it does is give you the values for your latitude and longitude location. You can use simple IDE to display the coordinates. This is the code we used to get our GPS values. So yeah, the simple IDE's library has built-in functions to get those values. Here's our demonstration.
And for the next component, we did a camera and video. So we hooked this up to the Raspberry Pi, which is a USB webcam. It can do a live stream video and take snapshots of current movements. But the thing that we also made it configure was not taking a snapshot when there's no motion detected. And here's a brief demonstration of that. So here I'm running my motion start on through the Raspberry Pi's terminal, typing in the IP address for the live stream. And here, as you can see, the USB is doing a live stream of what's actually going on. And as you can see the webcam moving. And the red box around it is what detects the motion.
So another component that we added to our user interface was an IR receiver and remote. Along with the button system that we can use to set the alarm, we can use a remote using an IR receiver. The IR receiver takes in the signal from the remote and gives us a value, and we can use that value to make it interact with our parallax. This is the code for it. It's pretty simple. It has a built-in function to take the value of the button. This is our demonstration. So finally, after seeing all those components, we put them all together into our final project. And we made our code to make them all work in tandem with each other.
Do you have one more?
Just the code. was it, and this is the code that we used to make it all run together.
Louder.
Okay. And so this is the code we used to we put together to make all those components run with each other. Do you want to see the live demo?
So here is a live presentation of our demo that we set up.
So right now the parallax is on standby mode, and you can see by the green light that it's on standby mode. And the LCD displays that it's on standby mode. And so we also added another function where the LCD will display the GPS values that we had. So we press another button to display the GPS values, and as you can see here. And then we can go back to the standby mode for the alarm by pressing a button again. So now it's on standby, and now we can set the alarm. And now the orange indicates that it's on set, but it's not triggered yet, and the LCD display says it so. So now we will trigger the alarm. So you can see the alarm going off and the LCD display going. So we can press another button to turn it off. And there we go, and that's the alarm system.
And secondly, we use the USB webcam as our live feed. So whenever it detects a motion, which we see here with this red box, you can see that my lab partner is being focused heavily, and as you can see, there are many files being saved for every event gap. At every 30 seconds, the webcam would take a snapshot of the best one and save it as a JPEG file. And lastly, when that works, you can see that the email that we set it as is notifying it as an intruder alert right here. As you can see, it's 9:22 p.m. and you can look here, about the same time as well.
And that concludes our CPE185 final project presentation. And again, I'm Jeff Valdez.
And my name is Harry Fun.
And my name is Chang Yao. Thank you.